Right, so we're going to look at properties of logs and how to use those properties to expand and condense logs. And this is important information when we start in the next section to talk about solving equations involving logs. So we have basically 3 or 4 properties that we have to consider. So the product property says that if I have a product inside the parentheses for the log, then that can be rewritten as the log of m plus the log of n. So I can rewrite any property that involves that. So if I have, for example, log base 6 x times 4, I can rewrite that as log base 6 x plus log base 6 4. Okay, so same thing for quotient. If I have a quotient inside, I can rewrite it as a subtraction, log base m or base b m minus log base b n. And the power property says that if I have some value raised to a power, and this can also be rewritten like this, log base b m to the p power, can be the same thing, then I can change the problem and I can bring the p down in front and write it as p times the log. So these are all properties that we're going to be using today. So let's look at this. So the first thing we're doing is we're expanding these logs. So the first thing we look at is that we have a quotient. So anytime you have a quotient, I'm going to rewrite that as subtraction. So log 100 minus log xy cubed. So now looking at this part, this is a product, right? So I can rewrite a product using addition. So I have log base 6, log x and log y cubed. Now I'm going to distribute that negative sign, and I end up with log 100 minus log x minus 3 log y. So I'm going to bring that 3 that's a power down in front. And I've expanded it to that. So again, I went from division, a quotient, to subtraction, and then I went from a product to addition, and then I distributed that negative sign because this is minus the whole thing, and I end up with this, what I have right here. So now the last thing I have to remember is that log 100 is the same thing as log base 10, 100 equals x, which can be rewritten as 10 to the x power equals 100. So 10 to the x power would be 2. So 10 to the second power equals 100. So my final answer is 2 minus log x minus 3 log y. So that's how we expand logs. Okay, so here's another one. Alright, so again, I'm going to take this quotient and separate it into subtraction. So I have log, or ln, e square root of y minus ln z cubed. So there's a couple things going on here. Right here, I'm multiplying e times square root of y. So I can break it into ln e plus ln square root of y. And then again, I have that minus ln z cubed. So z cubed is eventually going to be brought down. So now this is what I've got to remember. ln square root of y is the same thing as y to the 1/2 power. So anytime we have the square root, it's like writing it to the 1/2 power. So now this can be rewritten as ln e plus ln y to the 1/2 minus ln z to cubed. So the 3 can come down, right, because of the power property, and the 1/2 can come down. So I end up with 1/2 ln y minus 3 ln z. Now this is the other part you've got to remember. ln is the same thing as base e. So basically I'm saying ln base e equals x. So I'm saying e to what power equals e. So that would be 1. So you can also check those in your calculator. So if we do ln e in our calculators, we should come up with the value of 1. So that's one way of explaining it, but you can also understand how it works mathematically. Okay, so that's our final answer. That's our expanded logarithm. All right, so here's another one. So we have base 5 this time. So again, I've got a quotient, so I'm going to separate the quotient, I skipped a step here, into log base 5 z to the 4th square root of x minus log base 5 125. So again, the product over here will become addition. So I have log 5 z to the 4th plus log 5 square root of x minus log 5 125. Square root of x can be rewritten as x to the 1/2. So I end up with this. And then the z to the 4th, the 4 comes down in front. The 1/2 comes down in front. And then again, we've got to remember our properties here. So 5 to some power equals 125. So x would equal 3. So this whole term here equals 3. So this is our final expanded log. Okay. So now we're going to do the opposite action. And now what we're going to do is we're going to condense the log. So what we want to do now is we want to take the long log with the addition and subtraction, and we want to condense it into this. So we have to look at each part. So we're going to start with our brackets, and we're going to say addition changes things to multiplication. That 3 in front is going to come up as a power. So I'm going to have, for example, over here, 3 log z minus 1 is going to become log z minus 1 to the 3rd power. So now I'm doing the product. Since it's addition, I'm going to change it to product. Okay. And then the minus sign means it's going to change to a quotient. So I'm going to take x squared over all of this. So the one thing I need you to remember is that you're going to have one log in front. Do not write log x squared over log y. That's a different problem. So that's how we condense logs. So here's another example. First thing I'm probably going to do is bring that 1/2 up. So I end up with a problem like this. And then I'm going to bring that 3 up. So I end up with a problem that looks like this. Okay? Now, anything to the 1/2 power is the same thing as a square root. So that's how I came up with the log base 8 square root of x plus 5 minus log 8 y2 cubed. Okay, so now subtraction again means I'm changing it to quotient, and so don't forget to write the log base 8, and then here's my quotient problem, and that's our condensed polynomial, or our condensed log, I'm sorry. Alright, here's another one. So for this one, we're going to bring our 3 up and make it y cubed. Addition means it's going to change to a product. So I have x squared minus 4 times y cubed. And then over here it doesn't change. So now I have log base 5 x squared minus 4 times y cubed minus log base 5 x minus 2 squared. So subtraction changes it into a quotient. So I end up with log x squared minus 4 over times y cubed all over log x minus 2 squared. So doing a little bit of algebra, the x minus 4 squared becomes x minus 2 and x plus 2. And then I have x minus 2 on the bottom. So the x minus 2's cancel out, and my final condensed log is log base 5 x plus 2 times y cubed over x minus 2. Okay, so another thing that we'll be using frequently is what we call a change of base formula. And remember what I told you on your calculator, that there is not a log base problem. There is one, but we're not going to talk about it. So if you try to use the log button on your calculator, you're always talking about base 10. Well, what if you're not talking about base 10? So for example, on this one, we're looking at log base 8. Let's see if I can clear this up a little bit. Okay, so we're looking at log base 8. So log base 8, I can't put that in my calculator the way it is, so I'm going to use a change of base formula. So the change of base formula means the base always goes on the bottom and the x always goes on top. So I'm going to do log 75 over log 8. If I put that in my calculator, and I am going to put log both times, so I'm going to do log 75 over log 8, and I end up with 2.07. Okay, now the thing that's nice about this is that it works for ln also, so I can do ln 75, I forgot to do it, divided by ln base 8, and I still get 2.07. So it doesn't matter whether you use ln or log, the change of base formula will work. Okay, so here again, change of base, so we have log 5.5 and log square root of 3. So if I put that in my calculator, I get 3.10. Okay, so again, what that means is square root of 3 raised to the 3.10 power is going to be 5.5. So you could always check it. It's not going to be exact because we're rounding it off. Square root of 3 raised to the 3.10 power equals close to it, 5.5. 5.48 rounded off is 5.5. Okay? Alright, so our last thing that we're going to look at, oh, here's one more problem with change of base. So here's where you really might need to use change of base. So if I needed to graph this polynomial, I would have to put it in my calculator like this. So in my calculator, I've got the log 2x plus 3 and log 3. Depending on what my window's at, if I try and graph it, I could get an error. So if I set my window at like -2, let's just do that and you'll see what happens. I immediately get an error. So what I did is I changed my window to 0 and I graph it and I can see my graph coming through. So remember that you can't have 0 or negatives for my log, so this value has to be greater than 0. So technically my x-min can't be less than -1.5. And if I go to my table, oops, my table's set up wrong, so let's do my table settings. And I'm going to set my table settings at -1, and then I can graph it, and I can look at my table. So at -1 it's 0, and if I go up 1, again I'm going to get that error. But I can still look at my graph, and I can see what my graph looks like and possibly get some points to graph it with. Okay, so the last thing that we're going to do here, an example of logarithms is dealing with the Richter scale and the magnitude of a Richter scale, or the magnitude of an earthquake. So M is the magnitude of the earthquake, I is the intensity of the current earthquake, and I0 or I sub 0 would be the intensity of an earthquake at level 0. So when we're trying to figure out the magnitude, we're always comparing it to that magnitude at 0. So here's an example. It says, find the Richter scale magnitude of an earthquake with an intensity of 8,250,000 IO. So that means that the intensities are always based on what an intensity would be for 0 earthquake. So we substitute that in. We're looking for the magnitude. We have log. Here's our I value. Here's the IO that we don't have an exact value for. Notice the IOs can cancel out, and I'm left with log of 8,250,000. So if I actually put that in my calculator and I do log of, log of 8,250,000, I end up with a magnitude of 6.9. So this earthquake would be a magnitude 6.9. All right, now here's another one. What if I have an earthquake and I say the magnitude's 9.2? What's the actual intensity? So I have log, here's my formula. I put the 9.2 here. This is a base 10 problem. So 10 to the 9.2 equals the intensity. And then I can go through and find that and put 10 raised to the 9.2 power, and that's how I come up with my intensity.